So hello everyone, and today we are going to discuss proton NMR spectral interpretation. Okay, so in this we will explain the examples how you can interpret the NMR spectra. Okay, and some problem I will also solve. Okay, so come on the first slide. In this slide I have added the nuclear magnetic resonance, means we have added the chemical shifts. Okay, so suppose that it is your spectral. Okay, and it the chemical shift which appeared from 0 to 12 or 13. Okay, and these are the some functional group, means specific functional group, and their chemical shift which are mentioned in this spectra. Okay, so by seeing this you can examine other spectra, means other organic compounds. Okay, suppose that from in your NMR spectra acid peak present, so acid peaks appear in the region of 10 to 11. Okay, and aldehyde will appear in 9 to 8, 9 to 10. Okay, so by this interpretation you can interpret the NMR spectra. Okay, so come on the first slide, come on the second slide, sorry for that. In this slide I have added some chemical shapes of different aliphatics. Okay, so aliphatic, you should be know that aliphatics appear 0.82, here 1.7. Okay, and if there is double bond triple bond present, then it becomes desilted. Okay, desilted means comes downfield region. Okay, and it became in, means the del value of proton in when double or triple bond will present, it will increases. Okay, due to electronegativity. Okay, and aromatic region appears. This is the aromatic protons. Okay, aromatic attached at ipso, means methyl group is attached from benzene. Okay, so these cs3 appeared in 2.2 to 2.5 due to presence of aromatic ring. Okay, similarly if you see this one, this is the R group. Okay, R may be other electronegative atoms, or you can say electron withdrawing group. Okay, so that's why it becomes increases, means it appears 2.3 to 2.8. Okay, similarly you can see ROH. So ROH will be appeared in 0.5 to 6.0. In between it can be appeared. Okay, RCH2OH, it appears in, this is the aliphatic alcohol, you can say primary alcohol. Okay, and it will appear in 3.4 to 4.0, like that. And in this, suppose that you here hydrogen is replaced by R group. Okay, so here the chemical value increases, means it shifted. Okay, to 3.3 to 4.0. Similarly you can see this amine. Okay, so amine will appear in 0.5 to 5.0. Okay, similarly you can see RCOCS3. Okay, so since CS3 will appear in 1.2 to 1.4, but due to presence of CO, okay, the peak chemical shift will increase 2.2, 2.1 to 2.3. Okay, similarly you can see this one. Okay, so it will appear 2.2 to 2.6. Okay, so in these candle values you can see that aliphatic peaks appeared in 0.8 to 1.7. Okay, and it will enhance due to presence of R group. Okay, so if R group will present, then aliphatic del value will be increased. Okay, similarly the effect of electronegativity is also appeared, and the del value will be increases. Okay, so you can see other ether or OH group, it will appear in 3.4 to 5, 4.0. Okay, similarly amine will appear 0.5 to 5.0. Okay, and so here you can see the elect when electron releasing group attached with carbon. Okay, so that's why it become, the proton will be desilted. Okay, and electronegativity also affects the del values. Okay, again you can see this Similarly, it is very important. Uh, if you see this one, RCH2 ion, RCH2 bromine, RCH2 chlorine, and RCH2 chlorine. Okay. So in case of RCH2F, okay, so del value become more enhanced as compared to iodine. So it is due to the electronegativity effect. Okay, when electronegativity increases, the del value shifted to downfield region, or you can say distilled region. Okay, aromatic alcohol appeared in 4.5 to 4.7, and RCH double bond CH2. You can say these are the uh, vicinal protons which appeared in 4.6 to 0.50. Okay, aromatic proton appeared in 6.5 to 8.5. Aldehyde protons appeared in 9.5 to 10.1. Okay, similarly you can see acid proton appeared in 10 to 13. Okay, so in this range you can see these protons. Okay, similarly, in case of types of hydrogen, okay, so it may be either primary or secondary or tertiary, okay. So it will appear in chemical shift 0.8 to 1.7, okay. So actually, I have put it these common range, okay. And in this double bond is present, it can you can say allylic protons. It will appear in 1.6 to 2.6, okay. Like triple bond appeared as 2.0 to 3.0, okay. Similarly you can see these one, okay. So these are the vinylic protons which appeared in 4.6 to 5.7. Aldehyde appeared 9.5 to 10.1, okay. Here fluorine, due to electronic effects or electronegativity effects of X, it will appear 4.0, okay. And okay, so CS3OH appeared in 3.5, okay. Chemical shift actually appeared in 3.47, but due to electronegativities of X, it will appear in distilled as compared to normal range. Okay, so it is the most important is tetramethylsilane, which appeared in 0.00. Okay, here X, due to presence of X, it, okay, so it appeared in TMS peaks appeared in 0.00. Okay. You can see this spectra. Okay, so in this spectra you can see this benzene ring attached with HX and MS distereotropic protons, okay, and other and near carbon is attached with 2 methoxy and 1 proton, okay. So 1 protons appeared as a triplet, okay, due to n plus 1 rule, okay, and for these protons it will appear as a doublet. HX will appear as a, you can say, doublet, okay. So for this HX doublet will be appeared, and for this HA triplet will be appeared, okay. And aromatic protons appeared in own range, okay. And this NMR spectra has been carried out in 19 megahertz, okay. How, what is the difference between 19 megahertz and 100 megahertz, 500 megahertz? Actually what happens here, when you apply 90 megahertz, the peaks will appear near, okay, means compactness will be appeared. But in case of 500 megahertz, the peak will, means the distance between two peaks will be large, okay. So you can interpret it very easily, okay. Similarly you can see this spectra. So for these protons, what happened here, quartet will be appeared, okay. So these protons appeared as a quartet. For this proton, triplet will be appeared, okay. And you can see, not actually, it is symmetrical molecule, okay. It is symmetrical molecule. So that's why for this proton it will appear as a triplet, okay. And for this it appears a quartet, okay. So, and if you see this one, so this is the, for this proton doublet will be appeared, okay. And for this proton doublet will be appeared. So two doublet and one quartet will be appeared, okay. And one triplet is also appeared in this region, okay. Similarly you can see this one. So for this proton it will appear as a triplet, Okay, triplet for this proton appeared as a triplet. Okay, and this triplet will be appeared for four protons. Understand? Okay, for four protons. And okay, and if you can see, for this proton triplet will be appeared, and for this proton you can see what will appear, 2 to 4 means pentane will be appeared. Okay, so oxytane represented one pentane and one triplet. Similarly, you can see this compound. Okay, so in this compound what appeared, methoxy will appear 3.8. This proton will appear as singlet. Okay, so one singlet for two protons. Okay, since molecule is symmetrical. Okay, similarly you can see this one, and cs3 cs2 means one. For this proton triplet quartet will be appeared, so one quartet will be appeared for this, and for this proton triplet will be appeared. Okay, and the j value will be different. Okay, because these are the these are the geminal hydrogens. Okay, and these are the basinal hydrogens. Okay, so j value will be appeared because of interaction of ha with this one and this one protons. Okay, similarly you can see other compound for this. Okay, it is carried down 200 megahertz. Okay, so what happened here, for this proton triplet will be appeared, and for this proton quartet will be appeared, and this and these are the geminal protons. Okay, so that's why it will appear the doublet. Okay, and for this proton one triplet will be appeared. Okay, and one quartet, for this proton one quartet, and for this proton one triplet will be appeared. So by this methodology you can interpret these NMR spectroscopy spectra, sorry for that. So in case of paragynyl, what happened here, how many hydrogens are there? So there are only one signal appeared for six protons. Okay, because these will equivalent protons. Okay, how many hydrogens in each type, this will inform us the area of a signal. So only one type of hydrogens are there. There are functional group near each hydrogen atom, no functional group is present. And how many hydrogens are attached to the carbon atoms near each hydrogen types. Okay, so you can see this one, these are the ortho, these are the one type, two type, so only two type of hydrogens are there. So you can see this one, six protons will appear for this methyl group. Okay, so these are the sharp singlet will be appeared, and for this aromatic protons only what happened here, this singlet will be appeared for four protons. Okay, signal will appear, two signal will appear in paragynyls. Okay, similarly you can see this one, what happens here, the structure is tertiary butyl bromide. So 3 3 means 9 proton appeared in 1.8 ppm. Okay, similarly you can see this two types of protons are there, and one is triplet, for this b appeared as triplet quartet, sorry, and for this triplet will be appeared. Okay. Number of signal is spectra will inform us the number of hydrogen types in the molecules. Okay, so signal indicating the hydrogen type. Okay, area p signal indicates the number of hydrogens atom in each types. Okay, chemical shapes of del of the signal inform us the about closeness of hydrogens to the functional group. Okay, and splitting pattern of the signal informs us how many hydrogens are surrounding each type. Okay, so these are the, you can see this one is triplet, these are the doublet, and these are the doublet. Okay, so you can identify that triplet, doublet, and 2s, so you can interpret it. Okay, again you can see this one, and by applying n1 plus n plus 1 rule you can identify the splitting pattern. Okay, but you can you can uh, understand that if near bromine, if any electronegative items present, if more electronegative atom is present, then it will indicate the higher del values. Okay, as compared to lower electronegative atoms. Okay, So in this, bromine will affect this proton as much more as compared to this, and this methyl feels less electronegativity effect of bromine. Okay. Similarly, you can see this spectrum. So for this proton, septet will be appeared. For this proton, doublet will be appeared. Okay. So only two type of signals will appear. Okay. One is one is heptate, and one is doublet. Okay. Another, this is the another compound, and you can see one triplet will be appeared, means your compound having one cs2 and ch. So this is the cs2, this is the cs. So for this d, triplet will be appeared. One doublet is present, so that's why ch2 will ch will be present. So for these protons, doublet will be appeared. Two C is compressed, means multiplet will be appeared. Okay. So C, for this proton, multiplet will be appeared because near 3, 4. Okay. So C, it appear for pen, means multiplet appeared for this one, and sextet will be appeared for one protons. Okay. You can see this one. So the 3 to 5, n plus 1 by applying n plus 1, one section will be appeared. Okay. Similarly, you can interpret these NMR because due to presence of CS3 and CS2, one singlet will be appeared for 2.3, one triplet will be appeared, and aromatic protons will appear. Okay. So how many signals in this proton? Three types of signal is present. Okay, and one is doublet, triplet, one is quartet. Okay, and OH will be appeared. Okay. Similarly, you can see this one. This is the aromatic protons. Means one signal appeared for aromatic protons. B appeared for triplet, and this will appear for it. B appeared as a quartet, while this A will splitting pattern will be observed as a triplet. Okay, so you can identify these types of protons. Okay. Similarly, you can see the these. Suppose that any molecular formula is given and splitting pattern is also given, so you can identify these uh, the organic compounds. Okay. Similarly, triplet is appeared. So why triplet is appeared? Due to presence of cs3. Okay. So B appeared as a triplet. Okay. And B appeared as a complex. Okay. Because complex, and C appeared as a quartet. Okay. Not C appeared as a triplet because near CS2 proton is present. Okay, so similarly, you can identify this compound. So it is looking like that. Okay, so all these compounds you can identify. Okay, so so in this slide, okay, you can revise this, and we will again the lecture we will uh, explain or explain this type. Okay, means if any IR frequency is given and splitting pattern is given and molecular formula is given, then how you can interpret the NMR spectra. Okay, so it we will discuss late in second lecture. Okay, so thank you for all.